Hello students, and welcome to our lesson, our continuing lesson on tangent, cotangent, secant, and cosecant functions. And this time we're asked to solve for x in these particular cases. And we're asked to solve here for x when the secant of x is equal to 2. And keep in mind that x here is the angle, okay? We can also say that it's theta, okay, on the unit circle. It's an angle, it's not a ratio. And so to do this is actually pretty tricky. If this was, if we had a function like cosine of x, you could do cosine inverse. You've probably seen that before in your Algebra 2 or in your geometry classes. But there's no such thing as secant inverse, at least not yet anyways. Okay? So we really can only do this, we can only treat this if we work with our trig ratios. So I'm going to solve a this way. I'm going to say that secant of x is equal to 2, and I'm going to convert any of these to something that's familiar to cosine, sine, or tangent, because that's a little bit easier for me to work with. Well, in this case, just remember that secant is really equal to 1 over cosine. So I can say that this is 1 over cosine of x is equal to 2. Multiply both sides by cosine. I get 1 equals 2 cosine of x. 1/2 equals cosine of x. And this 1/2 should look familiar to you. Look on your unit circle now, because that's going to be a big help. So we're going to use unit circle. And if we draw out our unit circle and sketch it, we ask ourselves, where is cosine equal to 1/2? Well, that's right here. This point here is 1/2 root 3 over 2. We really just care about that part. And down here as well, this is 1/2 negative root 3 over 2. And again, we just care about this. But remember, we're not looking for this per se. That our answer should be the angle. So how much did we rotate to get here? Well, if you know your unit circle, you should know that this right here is 60 degrees or pi over 3 radian. And you also should know that this angle down here is 270 or plus 30 more, so that's 300 degrees. So you should know that in this particular case, it is 5 pi over 3 radian. And this gives us two possible answers. This and this here. You have two possible answers, and we have to narrow it down. So we have two answers, and we are going to narrow it down based on this criteria. This criteria says that the answer should be between 3 pi over 2 and 2 pi, so there can only be one answer, and that's 5 pi over 3. Okay? So we have to narrow down using the restrictions here. And the restrictions are going to be given to you. If you don't have any restrictions, then you write both. But in this case, you have a restriction, so the only correct answer that you can have in this case is 5 pi over 3. Okay? And that's not an entirely straightforward problem to do, but it all ties back to the unit circle and how well you know your unit circle. So I'm going to continue here, and we're going to look back at, oops, I underlined the wrong thing, excuse me, I underlined this part, I should have underlined this part. Okay? That was the answer for, that was the requirement for part A, not part B. Okay. All right, so now let's proceed, and let's try part B. And again, I'm always going to convert everything into these terms because we're given cotangent, and there really isn't an inverse cotangent button. So I'm going to convert this to something using tangent here. Erase this now. This is 1 over tangent of x is equal to root 3. Multiply both sides by tangent. That's what we get. Then divide both sides by root 3, and this is what we have. Okay. And now tangent is difficult. Tangent is actually pretty hard to figure out by looking at the unit circle, but we can certainly do it. So let me get my unit circle drawn here. And you have to know your unit circle very well in order to get this answer, in order to really make it work. So one of the points that I'm interested in here is this point, which is root 3 over 2, 1/2. So the tangent here of theta is y over x. So at this particular point, it's going to be 1/2 divided by root 3 over 2, root 3 over 2, which is going to give you 1/2 times 2 over root 3, which is in fact 1 over root 3. Okay? And you might be thinking to yourself, how do I know this is the point right away? Well, the only way to really know is to completely understand your unit circle. There's a couple other points you can try. You can try this point up here, but the tangent up there is 2 root 3 over 3. Okay. So that's one possibility. And we have to ask ourselves, what's this angle here? Well, this angle here is 30 degrees, or pi over 6. And the other possibility is actually in this quadrant here, where you have negative root 3 over 2, negative 1/2. So if you do the division or the work here, you're going to get the exact same result. It's just this value, but both of them are negative. And so you got to ask yourself, well, what's this angle here? How much did I rotate to get here? And once again, you really have to know your unit circle. This we know is a little bit more than pi, so that is actually 7 pi over 6. Okay. So two possible answers. We have to narrow it down based on this criteria right here. X is between pi and 3 pi over 2. So in order to get a singular answer, well, we have to use our restrictions here. So we know that the only answer here is that x is equal to 7 pi over 6. You can use your TI-83 graphing calculator to try it out, and you can probably get a good answer from there. Okay. All right, so that's two examples there. A was a little bit more simple because you can find the points for cosine very quickly. B is a little bit more difficult because you have to really know your unit circle extremely well to figure out where tangent is equal to 1 over root 3. Now let's proceed to the last problem, which looks at first like it's the hardest problem, but in this case it's actually simpler because your calculator does most of the work. So this problem here, there is no exact answer. It's really difficult, actually. Well, I shouldn't say no, but it's difficult to find an exact answer. So we're going to solve this one by graphing and finding the intersection. Okay. So I'm going to use my TI-8384 calculator. Let's go to your y equals. And I got some other stuff going on up here. Just ignore that for now. I'm going to graph tangent here. Cosecant down here. And remember, cosecant is 1. And we are looking for the intersection. While my graphing calculator, I want to point this out here. We're looking for the intersection. Just let the graph do its work its magic. And as always, we use the graphing calculator to help us, but if you're going to graph, you need to graph this whole thing by hand. Okay? The good news is that the restriction is actually helpful to you in this case because you don't have to graph the entire thing. You just need to graph part of it. So you can see that graph starting to show up there. And we're interested in the intersection, so that's this point here where the green and the purple lines touch, and this one down here, and they touch a bunch of times, but we just want the answers based on our problem here. That's between negative pi and pi. So between negative pi, which is here, and pi, which is there. So I'm going to replicate this graph here, and again, it is a requirement that if you're going to use graphing as a way to solve it, that's perfectly fine, but you have to show the graph. Otherwise, it's no work, no credit. And I only have to go out as far as, this is pi over 2. Just have to go out as far as pi. Negative pi over 2. This is negative pi. I'm going to put my scale on here in order to make complete sense of everything. And I'm going to graph using my grapher here to help me. I'm going to graph the tangent first. That's all of the purple curves. And I just needed to go between negative pi and pi. I don't need it to do a whole lot more than that. And then I'm going to use my green marker to graph the cosecant function. And I only need to graph it between negative pi, which is here, and pi. So I only have to do 2 u's here. And keep in mind that cosecant has a min and a max at these particular points. So it is going to look like this, where I have a u going down here towards 0, and I'm going to have another u over on this side at 1. And you got to think about where is sine at its max, because that's where cosecant is going to be at its min, and it's going to be right. Sine is at its max at pi over 2. I have this function right here. Okay. I mean, that's not perfect, but it gives you a really good idea. And then what we really care about is this point right here. What is that? And this point right here. What is that? Okay. Those are the 2 answers to my problem. So we're going to use intersection to find it. We're going to go to second calc, pick the 5th item on the list here. And I need to find the intersection twice. First curve, second curve. I think my screen is freezing up on me here. Let's try that again. Second calc, 5th item, which is the intersect. First curve, y equals tangent. Second curve, let's move it a little bit, so there we go. Second curve there. Let's take the guess, and we're going to guess at that point. And that'll give me, my intersection is approximately negative 0.905 and negative 1272. So this is approximately, this point right here is approximately negative 0.905 comma 1 or negative 1.272. And gosh, this is getting sloppy, so I'm just going to write it to the side here. X is approximately negative 0.905. Okay, that's one answer. And I need to find this point right here to get my other answer. I'm going to have to use the intersection function again. Second, calc. 5th selection. The green one, that's good. Take a guess as close as I can make it. Right there. Hit enter. And that's approximately 9.905 again, but it's positive. So X is approximately positive 0.905. Okay. And so the first problem here, we used our knowledge of the unit circle The second problem, we really had to use our knowledge of the unit circle. And then the third problem, because there's no exact answer, and you can tell by looking at this type of function here, when you have two trig functions that are set equal to each other, it is very rare that you're going to find an exact answer. And in the instructions to it should tell you to round. That's a good indication that you can use a graph to get the answer. Okay, and really it's just understanding graphing, and your calculator does most of the work and the calculations. Okay, so now we've kind of, in the past several sections, we've worked on mastering and understanding all 6 of the trig functions, and these last problems here really help us to complete the picture of the trig functions, all 6 of them, even if they're a little bit obscure. But if we ever have to face them, we know different methods and different ways to handle